This is All Things Ansys, a podcast from the technical support staff at PADT. Episode 102, quick look at what is new in electronics reliability in Ansys 2021 R2, and an update on news and events from the Ansys world. Greetings on this Thanksgiving-centric episode of All Things Ansys. My name is Eric Miller. I'm your host and one of the owners here at PADT. We recorded the interview for this episode right before the holiday break, and then, let me be honest, I forgot to record this bit over the break, so I'm doing it on Monday morning, actually afternoon now, November 29th, 2021, from my backyard here in Phoenix, Arizona. I hope that you're listening, if you're listening in the U.S., you had a great Turkey Day. My turkey came out great. I'm a big fan of roasting it in the oven with the convection turned on. I just finished the last bit of leftovers actually for lunch before recording this. So if I do nod off, that big sandwich is the reason why. Hopefully we have a lot to be thankful for, and you do as well. And one of the things that we are thankful for here at PADT is our long and wonderful relationship with Ansys as users, as resellers, as support providers, and as evangelists for simulation across the engineering profession. I looked this morning, and since PADT closes between Christmas and New Year's, we only have 4 more weeks before 2021 is over. So we'll have one more episode in 2021. It should go out on the 13th if I remember to record it. That will be our annual yearly wrap-up with the tech support team, and something that we always enjoy. And so we're thankful to be finishing up the year of 2021. It certainly wasn't as bad as 2020, but it wasn't the year I think all of us hoped for. So we're thankful that it's coming to an end, along with some other things. Something else I want to say that I'm thankful for is the Arizona weather, the winter weather here in Arizona. It's 75 Fahrenheit, which is about 24 Celsius, and I'm recording this from my back patio in the backyard. I think the sound recording equipment filters out the fountain and the cars going by, but it's really enjoyable out here, and the birds are enjoying the sunshine, as is my dog right now. So I'm also thankful for having such a great technical team to count on here at PADT. And speaking of which, right before the turkeys went in the oven, I had a chat with our jack of all simulation trades, Josh Stout, about some new features in Ansys 2021 R2 for those who are interested in electronics reliability. Let's listen in to what he had to share. I want to welcome Josh Stout to another discussion about Ansys products and new release of Ansys. How's it going, Josh?
Hey, Eric, it's going all right. I'm ready to eat some turkey.
Yes. We're recording this the Tuesday before Thanksgiving, and I'm of course questioning my heat transfer calculations because not wanting to get stuck without being able to get a turkey. I bought a frozen one quite early, and now I'm defrosting in the fridge, and I think I'm going to have to take it out and let it defrost in some cold water. It's not going fast enough. So, all right. So speaking of heat transfer, kind of, let's talk about electronics reliability, which is really important as we know in the world of today. Everything around us is electronics, and customers no longer accept that a part wears out after a little bit. Things have to last a long time. So Ansys, of course, has been adding a lot of capabilities in this area, specific tools, as well as capabilities in some of their flagship products. And there's a little bit in this new release, right?
Yeah, just a bit. I guess maybe the initial brief overview of electronics reliability is that we're mostly going to be talking about Sherlock. So Sherlock is a relatively recently acquired tool by Ansys. But it really focuses on PCB reliability. So it's a very, multi-physics kind of topic. Heat transfer, like you said, as well as mechanical and electrical and all of that, and how they interact with each other. But that's primarily the tool that we're referring to when we say electronics reliability.
Good. So let's start with Sherlock, and then we'll talk about some of those other products. What's the things that most excites you in the latest release?
Yeah, sounds good. So probably the most generally exciting thing for me is actually the documentation. So that's one of the things that they've known has been lacking in the last several releases, and they've been working diligently to resolve. But they've released an entire new theory manual for electronics reliability in Sherlock. So there are a lot of relatively complicated calculations that go on in the background that were kind of the, in some ways, maybe the proprietary part of Sherlock, just because those are the things that you would have to do manually before that Sherlock automates and really helps you out with. But they didn't necessarily tell you how those calculations were done before. So it's maybe a little bit hand-wavy, and I mean, you could accept that the results were good because of all the comparisons that they've released, but now we can, well, now we can read about it in even more detail. So it really helps the end user get a feel for what the program is doing and how you approach these kinds of problems.
Yeah, it's good. It's good news because my experience with it is that many of the things that we used to write custom code for or use spreadsheets to do, Sherlock is doing, and we know it by name, but we didn't really have the math behind it, right? So if you didn't write your own 20 years ago, you're kind of in the dark about it. So that's good to know.
Right.
Good.
And things like when you're looking at stresses on an element and you're basing some reliability calculations on those. Are you taking the stress inside of the board? Are you taking the stress at the surface of the board or at the component level? And those are all things that Sherlock had done automatically before, but it didn't tell you which way it was doing it. But now we know for sure, and that's informative.
Useful. Yeah, it makes me think about why we, and if you listen to the podcast, I talk a lot about how much I think Sherlock is such a great tool. And the two things that are difficult in electronics reliability simulation is one, the geometry, right? It's getting that electronic layout of the board and the layers and the components and all that stuff in creating a model that you can actually solve and run. And then the other is the multiphysics, like you mentioned. And it seems like Ansys is addressing each of those over time, adding more and more capability. So that's good to see. It's good to see.
Yeah.
So what else do you like in there?
Yeah, that's maybe a good segue to one of the other nice things in this release is that previously, if you were running a thermal mechanical study, Sherlock would actually use a solver called Calculix in the background.
Okay.
They just updated it so that it would run Ansys finally for thermal mechanical.
Yay!
Yeah, so it's helping to bring this entire simulation environment all together, all within the Ansys environment, so that you can really customize a lot more pieces of it. That's something new and exciting this time around.
That's great. It's another great example of kind of the process that Ansys uses when they acquire a company. Is they over time add capability, but they also increase the integration across products. And sometimes we forget how powerful that can be.
Yep. Good.
That's good to hear. And not easy. I feel for the developers to do that.
Right.
It's like doing heart surgery, right? That solver is built in the middle of this tool. So
yeah.
Good. What else?
Let's see. There are, kind of in that same theme, there are a variety of improvements made just for the Workbench connectivity. So it was just last release, 2021 R1, that they first added the integration nodes for placing Sherlock inside a Workbench. But there were still a few limitations there, like you'd have to actually create the Sherlock project in the standalone piece of software before you could load it in the Workbench.
Okay.
So now you don't have to do that. That's one thing. And there's also support for a couple of the other simulation types, like random vibration. You can now couple through the Workbench environment as well. So it used to be through the Sherlock interface. Now we can add some customization inside a Workbench and do all that too. So
that's really cool. Random vibe is a common later kind of simulation you'll do, and especially if you do a lot of aerospace electronics components, it's really important. So that's good to see.
Yep.
Good. Anything else got you excited in there?
So it's a little bit outside of my expertise personally, but electronics reliability also covers some features within other tools like LS-DYNA.
Okay.
So of course LS-DYNA is, at least as far as I know, it's most well known for explicit solving transient kinds of simulations with mechanics. There are some other sort of side features that we can make use of in electronics reliability, like solder reflow.
Okay.
So that's a really complex physical problem.
Right.
That involves some fluid behavior, involves heat transfer for sure, because you're looking at solder balls that are partially melting and then spreading across the surface, and all the mechanical stuff as well. So you're applying pressure with PCBs or die material or whatever's on your board. So being able to actually approach that through a solver like Elastina, I think is pretty neat. So I'm not 100% sure on the exact technology that enables that.
Yeah.
I mean, I'm looking at the release slides here, and it's talking about a fully implicit ISPG formulation, and those are mostly letters to me, but it certainly sounds exciting.
It's interesting because it's one of those calculations that we couldn't do in the past. And that Elastina is just perfect for, with the different kinds of explicit solvers that it has, where we can do these highly transient phase change. Is it a liquid? Is it a solid? Is it a viscous liquid? What the heck is it? It's really good at that. So I highly recommend that anybody that's interested in modeling that. So if you do chip packaging of any kind, or even reflow on PCBs, do take a look at that, because it's come a long way, and we'll have to dig into it a little bit more. And it's funny because we used to get requests for consulting to do that, and we'd go, "We can't do that," but now we can. So we'll have to reach out to some of those customers and say, "We can do that now. Can we give it a try on some of your components and see how it goes?" Good. Is drop in there as well? Is that anything new in that area?
Yeah, there are a few improvements with drop testing. That's a combination between Sherlock and Elastine. Okay. So of course you can do all that in Elastine as well. I think most of the improvements in this release are on the Sherlock side, talking through Workbench. So being able to export that model for the board and all the components from Sherlock, and bring that into a drop test environment, whether that's mechanical or Elastine. That process has been improved somewhat.
Good. Yeah, and again, it's with these kind of components, it's the geometry, getting solvable meshable and solvable geometry from I don't want to badmouth electrical engineers, but what they need to make their parts is not as complete as what we need to do simulations. So anything to make that simpler is fantastic. So that's good news. Good news. Well, great. Like you said, some key stuff, not significant, and I'm glad they keep adding and keep integrating and keep adding functionality, and I'm sure the core solvers always speed up every release as well, so that's good news. And anything else you want to add before we take off?
I think that's about it for this release. I guess maybe the last thing I can add is something that's more relevant to my everyday kind of work.
Right.
There's a new beta feature for exporting EDB files from Sherlock. And EDB is the sort of standard Ansys format for electronics desktop files.
Okay.
So it used to be kind of a circuitous and awkward path to bring a Sherlock model from Sherlock into electronics desktop IcePack.
Okay.
So that's something that we can do, much more easily.
Oh, good.
It's a beta feature too. So I haven't played around with it too much, but I know it's there, and I'm sure I'll use it.
The key thing to note on beta features for anybody that sparked the interest of, because again, it's about geometry, right? So use Sherlock to create the model, then do your heat transfer in IcePack and electronics desktop. But the key thing about most beta features in Ansys is they haven't been QA'd. It's not that they don't work, it's that they haven't run it through rigorous quality assurance. So do try it out. If you find any problems, make sure you let your support provider know, because you're helping them find those bugs so they can release it. And maybe it's not 100% of the features may not be there as well. Maybe another reason why it's still beta, but do give that a try. That's a big leap forward in another integration. So even more, like I say, that's a big impact on your day-to-day. If you're doing this kind of geometry, it's a big impact. So good. Well, I will let you get back to work. And speaking of your day-to-day work, and we will. I hope you have a fantastic Thanksgiving with your family and everybody. And we'll talk to you next time about something exciting and new as well.
Yeah, sounds good. Thanks, Eric.
All right. Thanks. Have a good time. Bye.
Bye.
Okay, so a small editor's note here before we get back to the main podcast. The thumping you heard during the discussion with Josh was actually his cat insisting on getting into the room and banging on the door while Josh was trying to explain esoteric electronic geometry modeling. Pretty funny. But that's what that noise was, if you wonder. Anyway, back to our regularly scheduled podcast. Some great progress there, not as flashy as some releases, but useful for those who count on these tools to drive their designs and fix problems in existing designs. And as mentioned, it's a great example of how Ansys integrates codes and treats codes over time when they acquire a company like they did with the Sherlock code. So great example of both. If you do electronic simulation and you're not using Sherlock, give a shout to your Ansys provider and check it out. I think you'll be glad that you did. It's really, really a useful tool for all the reasons we talked about in the interview. Today, for our commercial, I'm going to advertise some open job postings at PADT. We're growing and expanding and have several Ansys-related openings. As you can expect, as Ansys keeps acquiring people, we need to acquire engineers to help support it and salespeople as well. So several of the openings are regional sales positions, and we also have an opening for enterprise Ansys sales as well. If you're in sales, have thought about moving to sales, or know someone who is a smart salesperson, send them our way. We'd love to talk to them. The positions have various locations. They need to be in the southwestern U.S. for the sales positions, but the other ones, the engineering ones I'm going to talk about, are a lot more flexible in where they can be. And those are, we're looking for an Ansys customization software developer, so somebody who likes to do scripting and software development around Ansys software. An embedded software engineer, so somebody who writes embedded software code. This is to help with the SCADE tools, which we're seeing more and more of our users using. And speaking of new tools, we're looking to add an optics engineer as well who knows ZMax that can help us understand and support that product as it comes along in the Ansys acquisition train. And last but not least, we are on the lookout for a simulation engineer, structural thermal engineer that can help us on the consulting side of things. The other three are for support, but this last one is actually in the consulting team to help us. We're getting busier and busier with just structural and thermal simulation, and we could use some help there as well. To learn more, go to www.padtinc.com/careers, or just go to our homepage and click careers at the top of the page, and you can get more details on it and how to apply and what we're looking for. I do have to say that all these positions do require citizenship or U.S. residency, since we do ITAR work. So do check those out. Let's take a look at the Ansys stock. ANSS, which is what they go by on the stock market, has had its ups and downs recently, along with the whole market. In November so far, it's been as high as 409, closing price at 409. That's the highest close ever for the Ansys stock, and it's been as low as 382 this past Friday, right between Thanksgiving and the weekend. It is at $400, pretty much even right now at 3:20 Eastern when I'm recording this, which is 1:20 in Phoenix. So definitely doing better here at the end of the year than it was doing kind of in the middle of the year. Kind of caught up with where it was at the beginning of the year, and hopefully it'll finish the year strong as well. In fact, it's up 10% year to date, and that's a bit less than half of what the S&P 500 has done with a month to go in the year. Just have them catch up a little bit. There's no critical Ansys news that's come out since the last podcast. Some more announcements of partnerships and awards. One's worth noting. TSMC, the large semiconductor foundry in Taiwan and now moving to Arizona, as well as a few other places around the world, just gave the OIP Partner of the Year Award for Next Generation Design Enablement to Ansys. and it was for joint development of 4 nanometer design infrastructure and joint development of 3D fabric design solutions. So this is semiconductor down at the nanometer level, semiconductor simulation, probably I believe it's in the Apache product line, which we don't talk too much about here on this podcast, but big product in the semiconductor industry. And when TSMC hands on an award like this, it's important. It's a big deal. So congrats to that team on the Ansys side as well as on the TSMC side. We don't really have any big news here at PADT. We've been quiet and kept our noses right up against that grindstone over the last couple weeks, so nothing new to announce there. 3 articles worth of noting that I recommend on the Ansys blog. The first is not really a post, but it's a link to a webinar called How to Accelerate Product Innovation Successfully Scale with AI. And it's basically a bunch of experts, including people from Ansys, talking about using artificial intelligence to help make innovation and simulation better. So do check that out. It's from a group called IDC, and pretty useful information. And it's something that I think we need to watch because it's just in the early stages of how we can leverage AI in simulation. The second article, we often want to know how much RF radiation exposure your product is causing the human subjects that get near it, maybe your users. So there's a really good blog post on how Continental uses electromagnetic simulation for RF human exposure assessment. And that's what it's called, actually, how Continental uses electromagnetic simulation for RF human exposure assessment. And it's a great look at how one company, at least, is answering the question of what's getting into people from an RF radiation standpoint. And the third article for this episode that I point out as being worthwhile reading is a summary of what disk drive behemoth Seagate is doing with Ansys these days. They're a longtime Ansys customer. In fact, we supported a division of theirs when they were here in the Southwest for a little while. And they do some pretty incredible stuff. So it's called Simulation-Based Product Innovation, Endless Possibilities. So it's a great look at how they're leveraging many different Ansys products, not just mechanical and fluent, to drive their product development. On our blog, we have 2 posts to share. The first is called Ansys Pro Premium Enterprise, Electronic Licensing Adjustments and that was actually published by today's guest, Josh Stout. And it really, if you're using the electronics package, you should give it a read. It's how to kind of switch between the different licenses in the electronics product family. The second article actually won't go out till tomorrow. It's set to publish tomorrow morning, and it's actually a link to a video from PADT's Kang Lee, and he's been sharing some fantastic videos on how to use the Ansys Maxwell product in a lot of different areas. And this is exactly what he's talking about in this particular episode or this particular video. In specifics, he's looking at how to simulate an electropermanent magnet using Ansys Maxwell. An electropermanent magnet is a permanent magnet that you can turn on and off with current. So it's pretty cool stuff. And it's kind of cool to see, it's also called a soft magnet, how you can turn it on and off with current, and you can see the current and the magnetic field in Maxwell. So do check that video out. It's very informative. And again, like all of his videos, a great way to understand better how to use Maxwell in a lot of different ways and get a feel for the tool. We don't have any webinars scheduled right now for the end of the year. Usually don't in December. We might add one. We'll see. And PADT events going on right now. The only one of note that's coming up soon is I'll be hosting a talk with 4 female founders here in Arizona called DEI Impact on Career, Company, and Culture, a fireside chat with 4 Arizona tech founders. And basically, we're going to be talking to them about creating their own companies, what that's been like, and what they learned in their careers before they founded their companies, and how that's influencing the way that they deal with diversity, inclusion, and equity in their own companies. So I'm looking forward to the discussion. If you're here in Arizona, you should also know that the Arizona Technology Council Holiday Party, as well as the Yes PHX Winter Social, are both on December 8th. These are great events. I'll be going to both of them as time allows me to. I'll go to the Tech the Halls with the Tech Council first and then to the SPHX event. Both are always great events and a great kind of end of the year way to hang out with folks that we've been working with throughout the year. And that's it for this podcast. I want to thank you. Don't forget to subscribe to our newsletter at www.padtinc.com/opt-in and spread the word about this podcast. Please subscribe to it so it automatically downloads to your podcast listener of choice. And as always, do not hesitate to reach out. Thank you for joining us for the All Things Ansys podcast, episode 102. As a reminder, this podcast is not affiliated in any way with Ansys Inc., and the opinions expressed are those of the people on the show only and not of their current or former employers. For more information, visit www.padtinc.com/blog, and please share your thoughts and questions through an email to podcast@padtinc.com. See you next time.